So light reactions happen in the thylakoid. You have the thylakoid space, which is inside. You guys might remember this is our jelly donut. This is the jelly inside the thylakoid space. We have the thylakoid membrane, which is the crust of the donut. And then out here is the stroma, okay? Within the thylakoid membrane, we have proteins embedded all over it, okay? I'm just going to draw 4 example proteins, okay? One here is photosystem 2. It was discovered second, but it's involved first in the light reactions. These I'm going to call the electron transport chain and the proton pump. This is photosystem 1, discovered first but involved second. And this is ATP synthase. So what happens? First we water our plant. I'll use blue. Okay? So we water our plant, and our plant breaks down into hydrogen ions and oxygen and some electrons, okay? So the oxygen is going to leave. It's a waste product of photosynthesis. But what we're really interested in is these electrons from the water, okay? Those electrons are what are going to get excited by light. So light comes into photosystem 2. It's absorbed by light-absorbing proteins, which we call pigments, specifically chlorophyll, okay? So the light is absorbed by the chlorophyll, and the pigment takes these electrons that it got from water and gives them energy from light, okay? So the electrons become very high energy electrons, and they get passed through the electron transport chain. So they go from photosystem 2 to photosystem 1. Meanwhile, while the electrons are being passed through the electron transport chain, the energy in these electrons is being taken away, and it's being used to do work, okay? The work that it's being used for is pumping protons into the thylakoid space.
But don't you have enough protons in there already from the H2O?
We have some protons, but not enough to create a big gradient. So we want a lot of hydrogen ions in the thylakoid space, so we can create a very high concentration of hydrogen ions inside the thylakoid space and a low concentration outside in the stroma. That takes energy. If you remember back to our first semester, we talked about active transport. When you go against gradient, when you're pushing something into a place that's already crowded, that requires a lot of energy, okay? So the energy is coming from the electrons. It's being used by pumps to pump the hydrogen ions inside the thylakoid space, okay? Meanwhile, the electron, by the time it gets to photosystem 1, has no energy left. All its energy has been used to pump the protons in, but it gets re-energized. Gets re-energized by more light coming into photosystem 1, because photosystem 1 has pigment molecules just like photosystem 2 did. So light's absorbed here, and it energizes our electrons again. So our electrons get some more energy. And these high energy electrons are then passed off to what we call the final electron acceptor, the thing that's going to take these electrons and move them to the Calvin cycle. And that is a molecule called NADP+. Okay? So NADP+ takes some hydrogen ions that were laying around, takes the electrons, and it becomes NADPH, which we know is going to go off to the Calvin cycle. Okay. Now to finish the story, we need to say, why did we have to pump all these protons into the thylakoid space? Well, we pumped all the protons into the thylakoid space so that we could make ATP. And the way we make ATP is by using this enzyme, ATP synthase, which is embedded in the thylakoid membrane. it does facilitated diffusion, which means it allows, doesn't work very well, I let it dry out. It allows the hydrogen ions to go from where they're highly concentrated to where there's a low concentration. So that's going down a concentration gradient from high to low. It's a diffusion. It's a facilitated diffusion because it's going through a protein channel. And the reason it's going through the protein channel is the energy from these hydrogen ions is also used to do something. And I draw this little picture here. It's supposed to look like a wheel. If you guys ever looked at a water wheel, water cascades over the wheel and it makes the wheel move. And then that can do some work. Like a lot of times we do that in a hydroelectric plant to make electricity. Well, here, the hydrogen ions are what's flowing through, turning the wheel. And the work that's done is converting ADP into ATP. Okay? So then our ATP is going to go off to the Calvin cycle with our NADPH.